If Tn is equal to 1 plus 2 plus 3 plus 4 plus like this up to n, and for n is equal to 2, 3, 4, etc., Pn is equal to T2 divided by T2 minus 1 multiplied by T3 divided by T3 minus 1 whole multiplied by T4 divided by T4 minus 1 dot Tn minus 1 divided by Tn minus 1 minus 1 multiplied by Tn divided by Tn minus 1. Then find the value of P of 2012. Also find what is the limiting value of Pn as n tends to infinity. Are you familiar with the mathematical meaning of the symbol sigma or uppercase sigma? It stands for summation of a number of terms. For example, sigma of n when n varies from 1 to 5 stands for 1 plus 2 plus 3 plus 4 plus 5, which is the total range of n. Similarly, sigma of n square when n varies from 1 to 4 stands for 1 square plus 2 square plus 3 square plus 4 square. There is a symbol capital Pi which is written like this or this, which is the capital or uppercase pi symbol. In mathematics, this symbol is used to denote the multiplication or product of a number of terms. For example, pi of n when n varies from 1 to 5 is 1 multiplied by 2 multiplied by 3 multiplied by 4 multiplied by 5, which is same as factorial n. Similarly, pi of n square when n varies from 1 to 4 is 1 square multiplied by 2 square multiplied by 3 square multiplied by 4 square. Both sigma and pi are shorthand notations used in math extensively. We will use the pi symbol in solving the present problem. Of course, we will use the sigma symbol also. Using the symbol capital Pi or capital sigma, not only my writing will be less, but that will also familiarize you with the important symbol. Let's return to the problem. It is given that Tn is equal to 1 plus 2 plus 3 plus 4 etc. up to n, and for n is equal to 2, 3, 4 etc. Pn is equal to T2 divided by T2 minus 1 multiplied by T3 divided by T3 minus 1 multiplied by T4 divided by T4 minus 1. It will go on until Tn minus 1 divided by Tn minus 1 whole minus 1, finally multiplied by Tn divided by Tn minus 1. Now, in the term Tn, n is changing from 1 to n, but in the term Pn, remember that n is starting from 2 and then it is going on for integral values. Or by using the capital Pi symbol, we can write Pn is equal to pi of Tn divided by Tn minus 1 when n varies from 2 to n. Let us call it equation 1. Similarly, Tn is equal to sigma of n when n varies from 1 to n, that is 1 plus 2 plus 3 plus like this up to n, which we know is n multiplied by n plus 1 divided by 2. Let us call it equation 2. Pn is equal to pi of Tn divided by Tn minus 1, n varies from 2 to n, and that is equal to T2 divided by T2 minus 1 multiplied by T3 divided by T3 minus 1, and multiplication will go on. The penultimatum term is Tn minus 1 divided by Tn minus 1 whole minus 1 multiplied by Tn divided by Tn minus 1. Now, the first n minus 1 terms, that is from T2 to Tn minus 1, we club it in the square bracket here, and the final term, that is this term, we separate out here. Appreciate the fact that the quantity in the first bracket, that is the quantity here, is Pn minus 1. So we get Pn is equal to Pn minus 1 multiplied by Tn divided by Tn minus 1. Or by bringing this term to the front and this term to the back, we get Pn is equal to Tn divided by Tn minus 1 multiplied by Pn minus 1. And we know that Tn is equal to n multiplied by n plus 1 divided by 2. Therefore, we can write this term as n multiplied by n plus 1 divided by 2, that is the numerator, and the denominator becomes n multiplied by n plus 1 divided by 2 whole the minus 1 subtracted from the previous quantity, and the whole thing is multiplied by Pn minus 1. This is from equation 2. Then we can simplify that to n multiplied by n plus 1, and in the denominator it will be n multiplied by n plus 1 minus 2 whole multiplied by Pn minus 1, or that is equal to n multiplied by n plus 1 divided by n square plus n minus 2 multiplied by Pn minus 1. That is equal to, by factorization of the denominator, we get n plus 1 divided by n minus 1 multiplied by n plus 2 whole multiplied by Pn minus 1. Let us call it equation 3. And that is equal to n multiplied by n plus 1 divided by n minus 1 multiplied by n plus 2, and this term, by recursive use of this formula, we can write this term is equal to Tn minus 1 divided by Tn minus 1 multiplied by Pn minus 2, and so on. So on means this term also we can further expand into Tn minus 2 divided by Tn minus 2 minus 1 multiplied by Pn minus 3. Before going any further, please like, subscribe and share and hit the bell so you can be immediately notified for new uploads. It is completely free and only takes a few seconds, and you can always unsubscribe later if you want to. More importantly for me, if you like, share and subscribe, it would encourage me to make and post new videos for you to view. Also, if you know about any interesting problems that you would like me to solve, please upload it in your comments. Without further ado, let's proceed with the rest of the video. Thus, Pn is equal to pi of n multiplied by n plus 1 divided by n2 multiplied by n minus 1 when n varies from 2 to n. Note that the term Pn minus 1 in equation 3 gets assimilated by the capital pi symbol because it is a product and Pn minus 1 will be automatically multiplied to this when n varies from 2 to n. So Pn can be written as pi of n varies from 2 to n of the first term. Similarly, pi of n varies from 2 to n the second term whole divided by pi of n varying from 2 to n the first term in the denominator and pi of n varying from 2 to n the second term in the denominator. Here we have assumed that pi a multiplied by b is equal to pi a multiplied by pi b and also that pi p plus q is equal to pi p divided by pi q. In fact, this can be easily proved as you can try yourself later. Pn is equal to 2 multiplied by 3 multiplied by 4 up to n, then 3 multiplied by 4 multiplied by 5 multiplied by n multiplied by n plus 1 divided by 4 multiplied by 5 multiplied by 6 etc. up to n plus 2 multiplied by 1, 2, 3 multiplied by n minus 2 multiplied by n minus 1. And this term here is factorial n. This term here is factorial n plus 1, but as the number 2 is missing here, we divide that by 2. Similarly, this term here is factorial n plus 2, and since at the beginning 2 and 3 are missing, we divided by 2 multiplied by 3. Finally, this term is factorial n minus 1. Now a lot of things will cancel out from the top and the bottom that we have shown here. This factorial n will cancel with this factorial n. This factorial n will cancel with factorial n minus 1, leaving a term n in the numerator. Factorial n plus 1 will cancel out with factorial n plus 1, and these two will cancel out these two. So we will be left with n in the numerator and n plus 2 divided by 3 in the denominator, which is equal to 3n divided by n plus 2. So Pn is equal to 3n divided by n plus 2. We are asked to find out P2012, that is n is equal to 2012. So by using this formula, P2012 is equal to 3 multiplied by 2012 divided by 2012 plus 2. And by cancelling out terms, that is 3 multiplied by 2012 divided by 2014, we can cancel out 2 from the numerator and denominator to get 3018 by 1007, which is approximately 2.997. So value of P2012 is 2.997. Finally, the limiting value of Pn as n approaches infinity can be found out as follows. Pn is equal to 3n divided by n plus 2. By dividing numerator and denominator by n, we get Pn is equal to 3 divided by 1 plus 2 by n. Now, in the limiting case, when n approaches infinity, therefore, Pn is equal to limit of n approaches infinity 3 divided by 1 plus 2 divided by n, and this term becomes very small as n approaches infinity, so we can neglect it to get 3 divided by 1, which is 3. Because, that we have explained this. So the limiting value of Pn as n approaches infinity is 3. That is the second answer. Thank you.